Welcome to Spring LIB.
For this problem, we have to analyze two gears that are in contact. One of bigger diameter, the other a little bit smaller. This is gear A. This is gear B. And we know that the radius of the gear A is equal to 2 times radius of gear B. We are given in the problem the frequency of 0.955 Hertz. Also, we are given the angular acceleration, it's 3 radians square second, and the time. What we want to do the analysis is 2 seconds. The first part of the problem is well, actually, the problem is asking to find the revolution of each gear. So to solve this problem, we can have the following. We know that the frequency is the opposite of well, the hertz is the revolutions per second. So we can just express this as in radians, 2 pi radians 1 revolution, and this is going to be 6 radians per second. To relate these expressions we have and to know what are the revolutions for each gear, we can use the equation that relates the displacement equal to omega of the gear A times t plus 1/2 angular acceleration times square. So if we substitute the values, this is going to be equal to 6 times 2 plus 1/2 radial acceleration, angular acceleration 3, and time is 2 squared. If we solve this, if we do the math for this, we will find that there is 12 radians for this term plus 6 radians for this term, and the delta angular displacement is 18 radians. Again, if we want to convert this into revolutions, it's 2 pi radians, it's 1 revolution, and this is going to give 2.86 revolutions for gear A. To find the revolutions for gear B, we can use the equations that relate the velocity equal to the radius times angular velocity, and this can be for gear A, and similarly we can have for year B. Then we can solve. Well, we know that the radius A is equal to 2 times radius B. So BA is equal to 2 times RB A, and B RB omega B. Now we can, since we know that these two gears are in contact, we can assume at the moment of where the moment when they are in contact, that will have the same instantaneous velocity. So means that VA is equal to VB. So we can just make these two together equal. And we can, since RB and RB are the same, we find that the angular velocity of the gear B is equal to 2 times angular velocity of gear A. Also, we can assume that these two gears are going from rest to a certain velocity, WA, omega A, or an omega B, and we will have a different angular acceleration for each one. So if we want to calculate the acceleration for gear B, it's going to be equal to omega final minus omega initial over the time of 2 seconds. This is going to be 0 if we assume that we are starting from rest, and omega for the gear B is going to be equal to final gear B, that is going to be 2 times WA, and WA we found to be 6 radians per second. So times 6, and this over 2 seconds. We cannot see this properly, so I'm gonna write again. So it's equal to 2 times 6 over 2. This cancels, and it's 6 radians square second. Now we know the two acceleration. We know now the acceleration for gear B, and we can just apply the same equation to find the number of revolutions for gear B. So we have angular velocity is 2 times WA, 2 times 6 times the time is 2 seconds, plus 1 over 2 angular acceleration of gear B, 6 2 seconds square. And if we do the math, we find that this is equal to 36 radians. And again, if we want to convert this into revolutions, 1 revolution 2 pi radians, we find that the revolutions are 5, 5.7 revolutions, and this is for year B, and this is the solution for the problem.